So we can just borrow and not use our calculators again. In fact, when you guys are doing your homework problems and on the tests, just go back and borrow again. Okay? And don't necessarily think you have to compute everything, because a lot of times you're already going to have these computed. Okay? So we said that 7.3, that was going to be 35, I think, was it? Yeah, 35. And 5.1 is 5. 7.4 should also be 35. And 5.0 should be 1. 12.4 we know to be 495. So that's going to be 135 plus 35 is 270. Oh, sorry, 170 over 495. Is that correct, guys? No?
No. It would be 210.
210. So where did I get that from? Oh, I see what I did. I said 135.
Yeah, rather than 170.
Right, I didn't carry enough. Okay. So it's 210. Gotcha. Okay. And then somebody can go ahead and compute that, please. 424. Okay. Sounds good. So approximately 0.4. All right. So let me give you guys a minute to make sure all of this is okay.
These give a lot of irrational.
Well, it's still rational, okay? Because anytime
Well,
you,
that's true, it is rational.
yeah, it's all rational. There's just not as much repetition as you'd like to see, okay? And that's just because it's still an integer over an integer. It's just
Right.
not in the most simple form. Okay.
A lot more repetition.
Yeah. All right, guys. Questions I can answer before we move on. Okay, everybody feel okay about these? Okay, John, go ahead, sir.
Yeah, I'm not. I got something different. Like what? Like the last one, you had the 5 zeros.
Right.
So what I did, I started at 7054.
Mm-hmm. Now that's because this one was an at least problem. The last one was at most, okay? So remember, you have to look at the condition. So at least means you started that number, right? And then you work your way up. At most is where you start at 0, okay? So I think you might have just read that as at most rather than at least, okay? Does that make sense, John? Okay, that was just an accidental read, I think.
Oh yeah, okay, that makes sense.
Okay, good. All right. Other questions, guys, I can answer before we move on? Okay. So the last set of questions here, these are a little bit different than the other ones, okay? So we actually looked at some of these types of problems last time, okay, where we had like the fictitious words and we rearranged the letters. But these are a little bit different than what we saw before, okay? So before we even do any of the problems, let's try to think about what we did on Wednesday last week and how these differ. So just scroll back a little bit to, well, for me it's scroll, for you guys it's flip.
Ownership.
But the first problem we did involving combinations and permutations, we looked at the word ownership, okay? And I think we just used a bunch of permutations, or we used like the spacing method, right guys, where we just were able to utilize factorial sometimes, right? Now, I want you guys to flip back to the words that we're looking at now, like treetop, millimicron, success, okay? How are these words different than the word ownership that we looked at initially? There's some repetition, right guys? In other words, there's some indistinguishable L's, okay? There's some indistinguishable T's. There's some indistinguishable S's, right? So these are words that have some repetition in the letters, okay? So I want you to notice, guys, as soon as you see repetition, okay, these are all going to use combinations, okay? Because whichever T you pick, it doesn't matter which T you pick, right? They're indistinguishable from one another. It doesn't matter which E you pick. They're indistinguishable from one another, okay? So I don't want you guys getting confused as to when to use a combination, when to use a permutation. Okay? So everybody understands that, guys? Any questions before we move on? Okay. So let's kind of dissect the word treetop. Okay? So there's 2 T's in this word. There are 2 E's in this word. And then there's a R-O-P, right? All right, here's the way that we're going to set this up if there's repetitions in the letters, okay? If there's repetition, we know that there's a total of 7 letters in this word, right? Let's just say for some reason, the first letter that we're picking, or we're trying to decide what to do with, is the T's. Okay? Guys, if there's 7 letters and we only want 2 T's, wouldn't the combination be 7, 2, right? Now just go along with me, because you're thinking, well, what if I pick the E first? What if I pick the P first, okay? Wouldn't that change everything? No, it wouldn't, okay? So if you give me a chance to explain, so just follow along with me. So now I've gotten rid of the T's, right? I've selected those 2 T's. There are 7 spaces and I have 2 T's to pick from, right? Okay. Let's say I want to pick the E's next. What's the combination that would follow suit for the E's?
Same, 7 2.
Not
No,
7,
5 2,
2.
5 2.
5, 2, right guys? Because haven't we picked the 2 T's? They're gone. So now there are 5 spaces of which we want to fill them in with 2 E's. Okay? Now the 2 E's are gone. Okay, so no more E's. For the rest of this, there are what? 3 letters left, or 3 spaces left. We want 1 for the R. There are 2 spaces left after we select the R. We want 1 for the O. There is 1 space left, and there's 1 for the P. Okay, so this is one of several different setups that we could pick for this. Okay, so go ahead and copy that down. Okay, and then I'm going to explain why it works. Okay. But everybody understands, if I was to ask you to set it up, how that works. Okay, you just basically get a count, and then you just keep subtracting out once the spaces are filled in. Okay, so this is still sort of the space method, except we're not drawing out the spaces. All right, so I asked you guys, okay, how come it doesn't matter that I selected the T's first? What if I pick the R's first, or the P's first? Why does it not matter?
Does it still take off the same amount of space?
I'm still taking off the same amount of spaces. And guys, what am I really doing with all of those different numbers? Multiplying. Correct me if I'm wrong, multiplication is commutative and associative, right guys? And the formula, by the way, for a combination, correct me if I'm wrong, you don't have to copy this down because we already have it, is n factorial, r factorial, n minus r factorial. It's all multiplication. So when it comes down to it, guys, it doesn't matter, because you're still going to be subtracting out the number of spaces, which is the r each, or how many we're picking, n is the number of spaces available. So you're still going to get the same number no matter what. Okay? Does that make sense, guys, as to why it doesn't matter how you set it up? If you don't believe me, just go home and do all of, I think there's going to be maybe 8 or 9 possible arrangements that you can make with this. Do all 8 or 9 and believe me if you get the same answer. Okay? All right. Now our job is just to do some basic computations. We're done with this problem. Okay. 7-1, I believe, is 21. 5-2, I believe, is 10. 3-1 is 3. 2-1 is 2. 1-1 is 1. So 6 times 21 is 126. 126 times 10, 1260 maybe? So I can verify that just to make sure I didn't make any computational errors. Which is the bane of my existence because I want to get done. Okay. Yeah. I want to get done that stupid stuff with the computation. I'm always interested in doing the setups. Okay. Does that make sense, guys? Any questions? They're not difficult, right? It's basically the space method. Just write them out and just cross it out as you go along. By the way, another way you guys could have done this, okay, and this will work every time as well, you could set it up as 7-2, 5-2, and then since all the other letters are distinguishable, you could have done 3 factorial, okay? Because it doesn't matter, since there's 3 different letters, 3 times 2 times 1. In fact, that's what 3, 1, 2, 1, and 1, 1 works out to be. So that's another way to do it, especially if you have a lot of distinguishable letters or unique letters. Okay, that might work a little bit faster for some of you guys. If you don't like that, just do it the first way. Okay, it's a brute force method. Okay, all good, guys? Okay, let's try a few more of these. Okay, same idea, except this time now we have the word millimicron. Right, it's going to be the same thing. We just have to pick out the number of letters of each type and then just set it up using our combinations. Okay, so for the M, I think there's 2, right, guys? And then for I, we have 4. And, if I can count. Is it 3? Okay, thanks, I can't count. And then 2 for the L's, and then a CRON. Yeah, for each of those, I think we have 1 of each of those. So the milli is all the repetition, and the cron is the one that's unique. So now we just figure out a total number of the items that we're looking at. Okay. So it's going to be 4, 8, 11, I believe, is the total. And then just like we did in the previous problem, we're just going to go ahead, set it up, and then just multiply it out. Okay. So if I wanted to, and I just go right down the list whenever I do these. I just pick the M's first, and then the I's, and then the L's, and the CRON. It doesn't matter whatever order you want to pick them in. It'll still give you the same answer, as long as you do your computations correct. So if I wanted to pick the M's first, okay, what would be the combinations for this instance in selecting M's?
11, 2.
11, 2, right? There's 11 possible letters. We want those 2 M's. If I want the I's,
9.
that would be 9 and then 3, right?
Mhm.
Okay. And guys, remember, it's 9 because we picked those 2 M's. Those are done. You can't repick them once they're put in their places. Okay. Now we're done with the I's. Okay. So now we're on to the L's. So for the L's, what's that combination going to look like? 6, 2. Nice. We've gotten rid of 3 more letters, so that 9 minus 3 is 6. And then we want 2 of the L's. Okay? And then we could do 4, 1, 3, 1, 2, 1, 1, 1, or what's a little bit easier
4
way?
factorial.
Just 4 factorial, right guys? So I'm going to suggest, since there's 4 unique letters, that we just write that as 4 factorial for the CRON, okay? Because there's 24 different ways that we could arrange those. Okay, so we'll just say 4 factorial. Okay, is that good with everybody, guys? Any questions? Now it's just monkey punching the button, right? Okay, the rest of it's easy. Okay. 11, 2 should be 55. 6, 2 should be 15. 9, 3,
84.
84. That's right, we did that one. Why don't I remember that? And then 4 factorial is 24. All right, and then we just multiply those together, and we get some ungodly, useless number out of that. So I figured that out, and they'd be willing to share.
1,663,200.
Gotcha. 1663200. Look good to everybody, guys? Okay, nice. Okay. Guys, all we're doing here is basic arithmetic, right? We're setting up the problem, and we're letting the calculator do everything else. Okay, John?
You also do 11, 3, and 8, 2.
Mm-hmm.
So you could like switch.
Oh yeah, sure, it doesn't matter, because remember, it's all multiplication, commutative, and associative, okay? And whichever way you want to do it, that's fine, okay? My suggestion, though, is leave the unique letters for the end, so that way you don't have to worry about making more combinations than necessary, okay? Other questions, guys? Okay, so the next one is basically the same problem, except this time, we're now limiting what the positions for this, okay? So, for letter C, it's still the same word, millimicron, except the first letter must be an M. So we still have an M, we still have I's, we still have L's, and then we have CRON. Okay. Now, we started out with 2, right? But aren't we saying that the first letter must be an M? So basically what we're saying is that I've affixed the position of one of those M's. It's gone. Okay, I've basically taken it out of the theoretical bag of letters, and I have to put it in that first position. Everything else is going to stay the same. So that might be an easy way for you guys to be able to work with the problems where you're selecting one of them to start with. Okay, so just get rid of it initially, and then approach the problem in the exact same way. Does that make sense, guys? You're just basically crossing it out, and then you go ahead and just set it up as such. Okay. All right, so would we want to start with the M's this time, guys? No, let's start with the I's and the L's, and then we could just do a 5 factorial, right? That's way easier than trying to do more combinations. So, if I was to pick the I's, what's the combination that would represent I's? 10-3, right? Not 11-3, right? We have to use 10 because we've already selected one of the N's. So it would be 10 combination 3. Is that good with everybody, guys, as to why it's not 11? Okay. For the next one, which would be the L's, what would be the setup for the L's for the combination?
7-2.
7, 2. We picked 3 of the I's, they're gone. So now we have 7 letters. Of those we want 2. All right? The rest of them are all distinguishable. They're all unique elements. So couldn't we just do 5 times 4 times 3 times 2 times 1, or in other words, 5 factorial? And that's for the MCRON.
Oh, the first one is M, that's 1, okay.
Correct, right, because it's only 1, okay? Anytime you have a unique, just stick that in with the factorials. That makes it really easy. Okay, just stretching. Nope, you're fine. Okay, at this point, guys, let's just go ahead, compute it out, and we'll be done with this. Okay, we already know 7, 2 is 21. 5 factorial is 120. I don't know 10, 3 off the top of my head.
120.
120 as well. Oh, that's funny. Not really. It's I guess unprobabilistic would be a better word for that. So 120 squared times 21.
300.
30240. All right. Guys, any questions about this? Okay, same thing as we did before, except now we're just exhausting a couple of the decisions before we go through and finish. Okay. All right, guys. So for the last one we have here, now we're actually just picking maybe, or same sort of thing, except that we're just changing the word. So hopefully this isn't too difficult. So we have the word success. First letter must be a U. So we're going to do the exact same thing as we did before. We're going to list out the unique elements